Good morning, class. We're going to start notes over graphing linear inequalities in two variables. And so when we're doing this, we have three sets of information. We have a linear inequality in two variables. A solution of linear inequality in two variables is like a test point. And this test point is true. It's a test point that's true for inequalities. And it's usually going to be in the shaded area. Okay, so and then we have the graph of a linear inequality, very similar to a regular graph. However, I'm either going to have a dotted line or a dashed line, a complete full line, or things of that nature, and you'll also have a shaded area depending on the inequality that you get. So your first step is to solve for y. So make sure that you are solving for y. So you have to graph the line method, graph the boundary line using any method. So you can use a table, you can solve for y. That's what slope intercept is for. Okay, and you can plot x and y intercepts, or you can change the inequality. Or I'm sorry, your second step is to change the inequality to an equal symbol to plot the boundary line. So this is where you're going to change that symbol into any of these to plot that line. And number 3 says, should it be solid or a dashed line? We're not sure yet. And then our fourth step is to shade top or bottom and the test point not on the line. And here are a couple points that are usually easiest to kind of guess for. So when we're graphing, if I have to shade below, this is where I have y is either going to be greater than, or y is greater than or equal to. Okay? And it's a solid line, as you already know, if it's less than or equal to, an equal sign, or greater than or equal to. So if it has that equal to underneath, that's a solid line, and here's where it tells me I should shade above. If I need to shade below, this is where I have y is going to be less than, or y is less than or equal to. And if I have a dashed line, this is where I don't have the equal to. So I'm going to have greater than or less than as these symbols. Okay, so let's try an example using our steps. And recapping our steps, we're going to graph either using a table of values, slope-intercept form, or plot the xy intercepts. Okay, so now for our first example, we're going to graph the inequality below and name 3 solutions. And remember, solutions are if they are true. Okay, so let's go ahead and identify our slope. So it kind of looks like our slope-intercept form, so that number right in front of the x is 2 over 3. And our y-intercept is -4. So like normal, our first step, we're going to plot the y-intercept. And our second step is going to use our slope, so rise over run. So let's go ahead and go to our y-intercept, which is 0, -4. And then we're going to use our rise over run to plot the rest of our points. So I'm going to rise up 2 and go over 3. 1, 2, 3. And it is increasing because it's a positive slope. Down 2 and over 1, 2, 3. Okay, so now I've plotted my points, but I'm not going to connect my dots just yet. First, I need to know, do I have a solid or dashed line? So I have solid or dashed. So in this case, I have to go over to the rest of my table, and I see I have just a less than sign, so it is a dashed line. So I'm going to use a dashed line for this. Okay, so it's a dashed line because of my symbol. Then I'm going to plot the line. Okay, so there I have it, my dashed line. Okay, so we already notified that it is dashed, and it says test to point to the direction of shading. So this is my 5th step. I'm going to test a point. So let's use 0, 0. So remember, our note said we can use 0, 0 or 1, 0 as a test point. So we're going to plug in those for here. So we're going to plug in 0 for y. So I have 0 is less than 2/3 times 0 minus 4. So I have 0 is greater than 2/3 times 0 is just 0. So I have negative 4. So is this true or a false statement? This is a true statement. So this is true. And if it's true, that means I'm going to shade in that direction. Okay? So that means I'm going to take the entire thing and shade there. Okay, you may use a highlighter or you may use a pencil to shade. I'm shading everything above. And so now I can name 3 other solutions. So I can know 0, 0 is one. I can choose negative 2, 2 as a solution. And I can choose maybe negative 3, negative 3. So here are 3 solutions that make this true. So if the inequality is true, shade on the same side of the boundary. Same side of the boundary line as the test point. If the inequality is not true, shade on the other side. Okay? So now it says to name 3 solutions in the inequality, and we've named 3 solutions. We named negative 3 as a solution. We named 0, 0 as a solution. And we chose negative 2, 2 as a solution. Again, you can choose any points that are on that are not on the line but in the shaded area. Any points in shaded area. Okay. Now we can go on to example 2. And example 2 says graph the inequality below and name 3 solutions. So same method, however I have this in what looks like standard form. So method 1 is to solve for y. So we're going to try it for method 1. So solving for y. This means I have to move everything that's not with the y. So I'm going to subtract 2x from both sides. So then I have negative 3y equal to negative 2x plus 12. And our last step is to divide. So then I have y. So then I have y. Remember, we have to flip our sign because we did divide everything by a negative. 2 over 3x, and then we have minus 4. Okay, so our slope is 2 over 3. And our y-intercept is negative 4. Okay, now our other method is to graph using x or y-intercepts. So remember, if I want the x-intercept, I'm going to make y equal to 0. So that means I have 2 x minus 3 times 0. We're going to make this an equal sign just to find our x-intercepts. 12, so I have 2x equal to 12. When I divide by 2, I have x equals 6. And remember, if I'm trying to find my y-intercept, I'm going to make x equal to 0. And so from here, I'm going to plug in x for 0. So I have 2 times 0 minus 3y equal to 12. And so I have negative 3y equal to 12, and when I divide by negative 3, y is a negative 4. Okay, so that means for our points, we have 6, 0, and we have 0, negative 4. So those are 2 ways that we can graph. Okay, so we're going to plot the boundary lines. So let's go ahead and graph both of our points. So I have 0, negative 4, and then I have 6, 0. Okay, so it's a solid or dashed line. If this is a solid or dashed line, and in this case it is a solid line because I do have that equal to there. So there's my solid line. Alright, and note we did go the other way, so pardon my part, we did flip it because we did divide by a negative. So now we're going to test a point. Let's test a point. So let's use 0, 0. Let's see if that works. So we have 2 times 0 minus 3 times 0. And then I have here, that's if I don't switch it here, I have greater than or equal to 12. So I have 0 greater than or equal to 12. Is this true or false? It is false. So I'm going to shade other side. And what it means, if this is false, I'm going to shade the bottom half of this. So let's go to the bottom half. That's where I'm going to be shading. And then it says name a solution, or name 3 solutions in our direction. So we can name any of these points down here. So we can choose 4, -3. Or we can choose 3, -5. Or our last one, we can choose, I plotted my points wrong. Pardon me, that's supposed to be in 0, 6, not 5. Or our last one, we can choose 6, -5, or -4. So pardon that, I did graph this incorrectly, so I did fix it. 0, 6. Or I'm sorry, 6, 0. We have a solid line due to we have an equal sign underneath. And we can always use a test point, 0, 0, to give us true or false. In this case, it was false. So we have to shade everything else beneath it away from our test point. Then we chose 3 solutions that were in our shaded area. And again, they can be any 3 solutions as long as they're in our shaded area. At any point, you are welcome to pause and continue to write in case you're missing something, but I'm going to go on to the other side. Alrighty, we're going to flip to the other page where we have more practice. So the number 3 says graph inequality and name a solution to the inequality. So I have y is greater than 2 over 5x plus 3. So you can use any method. I'm going to use the slope-intercept form. So I know that m is my slope, and it's going to be 2 over 5, and my y-intercept is 3. So then I need to know, is this solid or dashed? Well, we have to look at our symbol, and we see it does not have an equal to sign underneath, so it is a dashed line. Okay? So let's go ahead and plot our points and make our dashed line. So we start at 3. And we're going to go up 2 and over 5. So I go up 2 and go over 1, 2, 3, 4, 5. And same, I can go below 1, 2 and go over 1, 2, 3, 4, 5. Okay, so there's my dashed line. Now I need to test a point to see if I need to shade above or below this line. So let's use 0, 0. So remember, with 0 and 0, we're going to plug these just right in here to see if it's true or false. So I have 0 is going to be greater than 2 over 5 times 0 plus 3. So I have 0 is going to be greater than 3. But is 0 greater than 3? No, so this is false. Okay, so that means I need to shade everything that's on the opposite side. Because 0, 0 is here, I can't use that as a solution, so I have to shade everything that's on the opposite side. Okay, so everything on the opposite side, because I cannot use 0, 0. Okay, So naming a solution, let's name one. So let's do somewhere I got -3 and 4. We can use that as a solution. Again, you can use any solution you want as long as it's in the shaded area. So let's try for number 4. I have it in somewhat standard form this time. So let's go ahead and solve for y in order to identify our slope and y-intercept. So I have to move everything over, signed it with -3y is greater than -2x plus 3. So all I did was move our 2x over to the other side, or I subtracted 2x from both sides and get here. Then I'm going to divide everything by -3. So now y is going to be less than, because we divided by +2 over 3x, and I have -1. Okay, so now I can identify the slope and my y-intercept. My slope is 2 over 3, and my y-intercept is -1. Now let's look at our inequality. Is it going to be a solid or dashed line? Well, this is going to be a dashed line because I don't have the equal to underneath. Now we can go ahead and graph our line. So we're going to start at -1, and I'm going to rise up 2 and go over 3. Okay, so I'm going to rise up 2 and go over 3. Go down 2 and go over 3. So there is my dashed line. Now I need to know if I can test a point to know which way to shade. So let's use our favorite point, 0, 0. Okay, let's use our favorite point, 0, 0. So I'm going to plug in 0. Doesn't matter which one you want to plug it into. I'm going to plug it into here. So I have 2 times 0 minus 3 times 0 is greater than 3. So I have 0 greater than 3. And is this true or false? This is false. So that means I have to shade everything that's on the opposite side. Again, because 0, 0 is here, I'm going to shade everything that's on the other side of this line. So now we can name a solution. And remember, any solution that's in the shaded area. So we can choose 3, 0, or we can choose 2, -4. I'm going to choose 2, -4. So again, you can choose any of those answers as long as they're in the shaded area. Okay, let's go on to our last, or our other practice. So now we have y is greater than or equal to -x. And so we already have it in slope-intercept form. So now we can recognize our slope. And our slope, if we don't remember, is that number in front of the x, and I have an invisible -1 there. So I have -1 over 1 as my slope. And I don't have a y-intercept, so that means my y-intercept is just 0. So this is a solid or dashed line. Well, this is a solid line because I have an equal to there. So let's go ahead and graph our point. So I start at 0. And then we have our rise of 1. So I rose up 1, I go over 1. Note it is decreasing because I have a negative slope. So there is my line. Now we have to test a point. No, I can't use 0, 0 this time because it's on the line. It has to be somewhere away from the line. So let's try 0, 1. So we're going to plug in y is 1, and then we have it as where it's greater than or equal to a -0, but there's no such thing as a -0. So I just have y is greater than, or 1 is greater than or equal to 0. And this is a true statement. And if it's true, I'm going to graph that same side. So wherever 0, 1 is, so I have 0, 1 is here, I'm going to shade that area because it is true. Okay, so now I'm going to name a solution. So I can name anything that's in that solution, including 0, 1, or I can choose -2, 5, because it's in the shaded area. So there are 3 examples on shading or graphing, shading and graphing inequalities. So let's go into horizontal and vertical lines. So horizontal and vertical lines. So example 6 says graphing inequalities below and still name 2 solutions. So just like we have vertical or horizontal lines, in this case we know we have a HOI because we have y equals, I have a 0 slope, so that means I have a horizontal line at my y-intercept, which is at 0, 2. And is a solid line because I have an equal to there. Okay, so it is solid. So now we need to choose a test point. I can choose 0, 0 because it's not on the line. So choose a test point. So I have 0, 0. And so if I were to plug in 0 for y, so I have 0 is greater than 2, but 0 is not greater than 2. So this is false. So that means I have to shade everything on the opposite side of my test point. So everything above. Then I can choose I can name a solution. So we can choose, for example, 1, 4. It's in the shaded area. Now if we're looking at B, it says graph x is less than -1. So remember, this is a vertical line because it has x equals, our slope is undefined, and we have a vertical line at our x-intercept, which is going to be at -1, 0. I'm going to -1, 0. And now I need to know if it's a solid or dotted line or dashed line, and it is going to be dotted. So there is our dotted line. And now I can choose a test point. And 0, 0 is a perfect test point because it is not on the line. So then I have 0 is less than -1. But 0 is not less than -1. -1 is. So this is false. So this means I have to shade everything on the opposite side of my test point. So that means everything on the left. So I've shaded everything on the left side. And now I can name any solution that's in that shaded area. And I can choose -2, 2. Or -2, -2. So again, these answers are going to vary depending on where you pick in your shaded area. So now here's 2 practice problems. So number 7 says graph the inequality and name the solution to the inequality. So I have x is greater than or equal to -3. So is this a vertical or horizontal line? Well, this is a vertical line because I have x equals and my slope is undefined. And my vertical line will start at -3, 0. So let's go over to -3, 0. Now it's going to be solid or dotted. And it's definitely going to be solid because I have that equal to there. Okay, so now we've graphed our line, and now we're going to test a point. So let's use our favorite test point, 0, 0. So I have 0 is going to be greater than or equal to -3, and this is a true statement. And if it's true, that means I'm going to shade that side. Okay, so I've shaded that side, and so a solution can be anywhere from 4 or 5. Or I can choose 2, -3. So as long as it's in the shaded area, any of these solutions are possible. And then we have one more, number 8. It's our very last one. And number 8 says y is less than 4. So I do have a horizontal line. I have a HOI because I have y equals, and my slope is 0. So I'm making a horizontal line at my y-intercept, which is at 0, 4. Now, is it solid or dotted? Well, this is definitely going to be dotted or dashed because I don't have an equal to sign. Okay, so now I need to know if I need to shade above or below. So our test point, and our favorite test point, is going to be 0, 0 because it is not on the line. So I have 0 is less than 4, and 0 is less than 4. So I'm actually going to shade that same side that 0, 0 is on. And now I can name any solution I want. And so let's try, we can do 2, -2. Or we can choose 5, 2. Or we can choose -3, -4. These are all in the shaded area. Any of these points are possible. So that concludes graphing inequalities. So that concludes our notes for graphing inequalities. I do have tutoring on Wednesdays before school at 6:45 to 7:15, as well as after school on Thursdays from 3 to 5 for JAG overtime, where a parent is able to let you go on a bus to take you home. Again, these notes will be on Canvas, on YouTube, as well as Remind. And if you have any other questions, please feel free to hit me up on Remind or send me an email. Thank you so much.